Here are 6 examples to factor trinomials using diamond and box method, a greater than 1. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to take 6 examples to factor trinomials. These are of the form ax squared plus bx plus c. We are going to use a very efficient method called diamond and box method to show a visual representation of this factoring process. Interesting examples have been taken. The trinomials which are given here, all 6 of them will be solved in this particular video. You notice that all of them have leading coefficient a, which is greater than 1. You also notice that there are some where the degree is higher. Even then, we can factor the trinomial. Only thing you notice is that this degree, the highest degree, is twice the one which is in the middle term. Right? Now let's talk about the diamond and box method itself. When we are factoring a trinomial, we are basically rewriting the trinomial expression in factored form using this method of diamond and box in this particular case. We'll also discuss with you some tips and how do we overcome some difficulties while solving the problems. Now let's look into the diamond type of a structure, which I've kind of changed, making a cross here. Now here I prefer to write the product on the top and sum vertically down. The idea is that the product, which is the product of A and C, the leading coefficient and the constant, should be placed and split into two numbers, m and n, whose sum gives us the coefficient b. So that is how all the 3 coefficients a, b and c are related. Once you are able to relate, you can place these values in the box and then factor. Now it's very simple. Let me just show you here. AC, the leading term, is to be placed on the left-hand corner, right? The constant C, diagonally opposite right-hand bottom corner. Do you see that? Just directly place them. Now the difficulty is to split the middle term B as sum of m and n, which also results into product of A and C. Once you do that, then you substitute those values, m and n, directly in the other two diagonals. And then we'll do greatest common factor to get the result. All right. Let's take the example before us to understand it fully. So here is our first trinomial, 2x squared plus 7x plus 3. How do we factor it? So as I said, the first term, 2x squared, comes on this particular square, which is left-hand corner. And the constant 3 comes right there. So we'll write the constant 3. Now we have to think about splitting 7 in such a way that we get the product of 2 times 3. So product is 2 times 3, which is 6. How do we split 6 so that we get a sum of 7? That is the whole thing. Well, 6 and work for us, right? So we could write m as equal to 6 and n as equal to 1. Because 6 plus 1 is equal to 7. Makes sense. So once you get these magic numbers, then it is very simple. Write 6x and 1x means just x in the other two diagonally placed boxes, which are empty, right? Now we know the two magic numbers, m plus n, whose sum is 7, right? 6x plus x is 7x. So we have filled the box. So this part on the left hand side is the diamond for us, right? And that is the box for us. How do we get the result from here is also very simple. You have to look for the greatest common factor along the rows and along the columns to get the result. I prefer to begin with the rows. So let's find the greatest common factor now for each row and each column. So if I begin with the first row, 2x square x, what is common here? Well, x is common. How about 6x and 3? 3 is common between 6x and 3. So that gives me first factor, which is x plus 3. Make sense? So easily we got our first factor. Now let's look into the column. 2x squared 6x. What is common here? Number 2 is common and variable x is common. So we could write 2x. Between x and 3, nothing is common, but 1, as you know, is always common, right? So we get the other factor, which is 2x plus 1. That is how we could factor the trinomial 2x squared plus 7x plus 3 using this method of diamond and box. Is it clear to you? Perfect. Let's take another example to practice. Well, in case you want to learn from me, feel free to send an email on globalmathinstitute@gmail.com. We are registering students these days. Well, here is the second example where the trinomial is 6x squared minus 23x plus 15. So straight away, we could always put 6x squared on the left hand top corner and the constant 15 in the bottom corner. The tip here is how do we split the product, which is 6 times 15, which is equal to 90, so that we get a sum which is minus 23, right? So minus 23. Since the product is positive and the sum is negative, both numbers should be negative, right? So we know one thing, that both are negative numbers, right? So what could they be? Sometimes it is challenging because 90 could have many factors. For example, 9 and 10. But 9 and 10 doesn't work because when you add 9 and 10, you get 19, not 23. So what could be the other possible combinations? And if the number would have been even higher, it was even more difficult. So here is another tip. How do we work with such big numbers? So in such cases, what you can do is do not write 90, but consider the product itself, which is between 6 and 15. Break it down into smaller numbers, means factorize them. So it is like 2 times 3 is 6 and 3 times 5 is 15. So that means you have to work with only 2, 3, 3 and 5 to get the result. Now it's very clear. If I group them like this, which is 2 times 3, 6 times 3, 18. 18 plus 5 gives me 23. Since I need negative numbers, I need negative 23, right? So minus 18 and minus 5 is the right combination. See the tip, right? So we have our m and n values, which are minus 18x and minus 5x. Reason to write this is because We are writing minus 23 in this form, right? You get the idea. So in fact, we'll split this and write like this. You see that? So you have seen how the trinomial has been expanded by splitting the middle term minus 23 as a combination of minus 18 and minus 5x. That is the technique, and these two numbers come in the other two places in the box. Get it, right? Now, the last step is to find the greatest common factor. Start with the rows. If you follow a procedure, it is better to always get it right and without much thinking. Great. So, in the first row, 6x squared minus 5x, what is common? Well, x is common. And in the second row, minus 18x and 15, what is common? Now, we will always keep x coefficient as positive, and therefore we'll take negative out, right? And 18 and 15 gives us a common factor of 3. So we have 3, and therefore we get our first factor, which is x minus 3. Is it clear to you? Perfect. Now let's look into the column 6x squared minus 18x. 6x is common. The second column, minus 5x and 15, will take minus 5 as a common factor. That gives us the second factor, which is 6x minus 5. With that, we complete our factorization using diamond and box method. Do you see how beautifully it has been done? Very easily. Perfect. Any doubts? Feel free to write your comments and share your views as you go along my solutions. I hope they help, right? Also, in case you want to support our channel, feel free to donate. You can do it using our email globalmathinstitute@gmail.com. Now let's look into another very interesting example. So just to begin with, 9x squared, the leading term, is being placed on the left hand corner, top corner, and 49, the constant, right hand bottom corner. Correct. Now we are reminded of product and sum. Actually, you should start with product and sum. Perfect. The product this time is 9 times 49. It's a very big number. So I'll prefer to just leave it as 9 times 49. But we'll use our tip number 1, which is how do we factor these two, right? Well, 49 is 7 times 7 and 9 is 3 times 3. So now these factors 3377 help us to get the value of m and n, whose sum should be minus 42. Minus 42 means both negative, right? So both negative. M and n are both negative for us. Perfect. So the sum has to be 42. Well, that makes sense. 7 times 3 is 21. And then we are also left with 21. So we get minus 21x. Clear? Right. So it becomes so easy. Do you see that? By factoring 9x squared and 49, the numbers, we get to know what could be m and n, and we found them to be 21 each. There is also an example of a perfect square, right? Right. If you look at the greatest common factor now, which is the next step, what do you notice? 9x squared minus 21x. So here 3x is common, right? And in minus 21x 49, minus 7 is common. So factor out the negative term, which gives us the first term, which is 3x minus 7. Absolutely clear, right? Let's look into the column now. 9x squared minus 21x gives us 3x as a common factor. Minus 21x 49, again the same thing, right? gives us minus 7. And so we get our second factor, which is 3x minus 7. So you see, it is a perfect square, which can also be written as 3x minus 7 whole square. Makes sense. So here we have utilized our tip, that is, factor the numbers whose product and sum has to match, right? So perfecting this helps you to really factor trinomials with higher coefficients. Now let's take another example. Here we have a higher degree. It is actually a very simple question. Now sometimes you may get confused. Well, we have been only doing quadratic equations. How come we have this? Well, think like this. We could substitute x square as some other number. Let's say p, for example. In that case, we could also write this equation as p square plus 11p plus 30. So in terms of p, which is x square, we could factor. So it is same equation. Do you see that? Instead of x, we are writing p. Rather, x square we are replacing with p. You get the idea. Let's do it. Now here, what is the product? Well, coefficient of x to the power of 4 is just 1. So the product in this particular case is 30, which is 1 times 30. And the sum we are looking for is 11, right? So 30 and 11, 6 times 5 is what gives us 30 and 11. So we can write the m value as 6 and the m value as 5. 6 times 5. We get all the numbers which we should put in the box. So that is the best way to do it, right? Now remember one thing, that in our equation we have x squared, right? Not x, and x to the power of 4. The leading term x to the power of 4 comes on the left hand top corner, and the constant 30 takes the position of right hand bottom corner. The other two, m and n, are for you 6 and 5. So 6, and remember the center term is x squared, which you're trying to split into 2, right? 6 and 5 x squared. Make sense? So we got our box with the values which we need to now. Greatest common factor. Next process. X to the power of 4 and 5x squared gives us x squared as a common factor. 6x squared and 30 gives us 6, right? 6 times 5. So we get our first factor, which is x squared plus 6. Make sense? The next one here, go for the columns. So x to the power of 4, 6x squared gives us x squared as a common factor. 5x squared and 30 gives us 5 as a common factor. So we get x squared plus 5. You can notice that if the coefficient, the leading coefficient is 1, then m and n values directly come, right? So in such cases, we can directly get a result, right? So I hope this process is clear. So here you learn, if the degrees are higher, even then we can use this technique of diamond and box method. Very beautiful technique, a visual approach to actually solve difficult questions. Let's take another example to understand this technique, right? Even better. Oh, this time I am taking to the power of 6 and 3. 3 times 2 is 6. So again, we can apply the same technique. Let me begin by writing the leading term 7x to the power of 6, just to remind you that now we are working with degree 6, right? And minus 54 as a constant. Perfect. Now once again, we'll not multiply 7 and 54. We'll just write 7 times 54 here, right? And to get the result, 7 times 54, we'll just factor 54 and see what can actually work so that we can get a sum of minus 3. Makes sense? Correct? Minus is the product, minus is the sum. That means the two numbers one of them is negative, the other one is positive. Negative number is larger. That is why when you add them, you get minus 3. Makes sense, right? Now, 54 is what? 6 times 9 is 54. Okay. So we can write 6 times 9. And 6 is what? 6 is 3 times 2, right? And 9 is 3 times 3. So we kind of prime factorized it. Now we are looking at the two numbers which are very close, just with a difference of 3, right? So if I look at this, what do I get? I get 7 times 2 as 14, and 333 is very far away. It doesn't really work, right? So now if I take 7 times 3 as 21, in that case I get my answer, right? So look here, right? If I take these, 9 times 2 is 18, and minus 7 times 3 is minus 21. So that works. Negative number is the bigger one of these two, right? And the smaller one comes there. Do you see that? Minus 21 plus 18 is 3. So it works. So we'll write minus 21, and remember x cube, right? This time these are higher powers, and 18 x cube. Does make sense to you? Now let's go for the greatest common factor along the rows and then the columns. So along the row, we get x cube for the first row and 21 and 54. What is common between these? Well, 21 is 7 times 3, correct? So 3 is also common in 54. So we get minus 3 as our factor. Take out, we want to keep the x coefficients positive, right? So we get our first factor, which is x cube minus 3. Makes sense? Now let's look into the second, which comes from the column 7x to the power of 6 minus 21x cube. So 7 is common and x cube is common. 18x cube and 54. So 18, you can see 18 is having 9 in it, right? 18 has got 9 times 2, right? And 54 is 9 times 6. So 18 itself is common, correct? 18 times 3 is 54, right? So we can take 18, sorry, not the x1, right? 18 itself is common. So we get 18 as our result, right? So the other term here is 7x cubed plus 18. Makes sense? So you see, so you see how easily we could factor this. We had higher leading coefficient 7 and constant 54. When you multiply, product is also a big number. We actually did not calculate the product. We prime factorized it to get the numbers. The key idea is to get m and n. Make sense? Once we got them, it was easy to get the result. So again, apply the tip to work with these examples. Make sense, right? Okay, you can always contact me on globalmathinstitute@gmail.com to learn more. Here is our last example, which I have kept slightly simple, but where you need to apply the techniques learned in this particular video. Right. So, how will you begin? Well, let's begin with product and sum. So the product we are looking for is 8 times minus 15. It has to be negative. So I'm writing minus first, and then, well, in case you want, you can multiply this and write a product. But I prefer to write only minus 8 times 15. And the sum is 2. How do we get these two numbers? I'd like you to now pause the video, get the answer, right? What will I do? Well, I'll split 8, and I know this is negative, just put negative to remind, and 15. So 8 can be split into 2 times 2 times 2, right? So 8 can be split into 2 times 2 times 2, and 15 can be split into 3 times 5. So we got these prime numbers to work with. You get the idea. So this is another way of just writing, because we are looking at these prime factors and figuring out what combination comes close. We know one of them is negative and one of them is positive. Since the product is negative, higher number is positive and lower number is negative. So we'll keep m as our higher number. Okay, great. So what can we do? Well, we need to get 2. So if I take 5 times 2, which is 10, I'm left with 4 times 3, 12. Do you see this combination? And then we have the others, 4 times 3, 12, 12 being higher. So I'll write m as 12, n as 10, minus 10. So we got our sum also. Do you see how beautifully and easily we got it? We never multiplied 8 and 15. Sometimes that could be difficult, right? Okay, let's now fill up all the data, the information from the diamond into the box. That is the logical step. 8x squared comes on the left hand top corner and the constant minus 15 takes the diagonally opposite position. M and n values 12 plus 12 x and minus 10x take up the next two values diagonally as shown here. Last step is to find the greatest common factor. As I said, we prefer to go by rows. It is your choice, however. So let's go with row number 1, 8x squared minus 10x. What is common? Well, 2x is common. The second row, plus 12x minus 15, we have 3 as a common factor. So we get our first factor from the row, which is 2x plus 3. Now, let's look into the column. In the first column, 8x squared 12x, 4 is also common, right, along with x. And in the second, we'll take away the minus sign. That is kind of important. And minus 5, since we want to keep the coefficients of x as positive. So we have 4x minus 5, and we have factored 8x squared plus 2x minus 15. Clearly, factoring means to write the trinomial as a product of the binomials, right? Which you get. And the tip used in all these questions was, instead of just writing the product, think about the factors of the number which you're multiplying so that you could get this beautiful combination of splitting 2x as we have seen here, plus 12 and minus 10x, right? Which gives us 2x. And that really helps. I hope it makes sense. Coming to the end of our video, in case you want to contribute our channel, feel free to contribute by sending an email, right? Every dollar counts. We have been serving you absolutely free for the last 15 years, and now we have more than 17,000 math videos which are watched over 80 countries. Your contributions help. Thanks a lot.